So some researchers here led by Dr. Vitali Sanye and some other Dr. Abdulrahim Bello and some others, including this young man standing on my side here, took it upon themselves to see how they can bring out something that will contribute towards having a real-time observation of patients with breathing issues. We all are aware, we are all witnesses to what happened during the COVID-19 period, how a lot of lives were lost because of lack of portable devices of this nature. So they were able to come up with this device. This is actually the prototype waiting for scaling and mass production. This is just the inside. It's called Smart Portable Ventilator. So at this moment, I will allow this young man, Olaji Brain, to give more insights about it, because he's actually a young innovator. He was part of the team that actually did this wonderful work of research.
Okay, thank you very much, Mr. Kingsley. Okay, so as my boss just mentioned, I'll give us a brief history of how this invention came to be. So it started from WPI, which is Worcester Polytechnic Institute. After the COVID-19, they felt like, okay, there should be a solution that can be easily accessible, and also cost-effective. That's for hospitals and small healthcares. So they gave out some kits whereby people actually developed to improve it further, to add more functionalities. And we were able to scale the first position in the competition, winning us some grants. And now with the help of that grant, we are trying our best to make sure that this device is fully ready for the market. We have done some tests in small hospitals. So my colleague will actually talk about how the whole product works. So I'll be handing it over to you, Gino.
Okay. Hello. Okay. Basically, what we did was to incorporate a kind of a smart feature where the device can be operated and viewed by the doctors or the nurses online remotely. So because during COVID-19, the what do you call it, the 6 feet, people could not really come close together. So we incorporated a smart application, if you can see it. So in the smart app, all the readings can be seen remotely without the doctors or nurses. Yeah, basically, yes. And also we incorporated a chat feature that can chat with an AI. It's not really big data, but yes. So in case it needs any help, like that's it.
So that is it. It solves the problem of enhanced mobility, real-time monitoring, unified patients data, holistic care, alternative energy source, and integrated backup system, and as well as noise reduction. So it's a masterpiece, of research and development. So I give it to AUSTInspire, who have done this job, and many more startups. And I'll still love to show you one or two again. Thank you very much. So earlier on, I made mention to you that part of what we do in AUSTInspire is research commercialization. That's taking research works to markets and producing actual products that can be taken to market. So here is one of the example here, and I'll allow our Director of Academic Planning, Dr. Bello, here to give us narration of these mass machines that have been fabricated here. Dr. Bello, welcome, please.
Yeah, thank you very much, Mr. Kingsley, and thank you very much for coming around. Just as Mr. Kingsley has said, we have some projects whereby we try to move our research from the laboratory to the market. One of our sponsors is Naseni. They are basically sponsoring this particular aspect of research that we are doing. And basically, this has to do with conversion of biomass into valuable products at the end of the day. So what you see here is a banana slicing machine. What this does is it basically slices the banana stem into 4 equal parts, which we now take to those other machines to extract the fibers from the banana stem. So although there's no power at the moment, but I can show you how it works. So basically, this chain here just keeps rotating. And then once you drop your banana stem on that, it just, since it is moving, It just
So drives
it to this blade here, where it passes through this blade. It divides it into 4 equal parts, and then you collect the product on this tray that is here. Now, from this tray, you now take those stem parts into the fiber machine. I don't know if you could move further so that I can just demonstrate to you the banana processing machine. So this is the fiber extraction machine. What this does is basically to extract the fibers from the machine. So you slot it, those stems that you have divided from there, you slot it into here. There's actually a wheel here that turns at a very high speed. So by the time it goes in, you pull it out, you get your fiber. You turn it to the other side, and then you just keep extracting your fibers, and you just keep it. So this is the major extraction system that is here. I know we've done a lot of work before, but this is typically how you get some of the fibers. I should have brought some fibers from the lab for you, but at the end of the day, the banana stem just comes out like a very strong fiber like this. But these are just samples. So this is a typical fiber. So one strand like this is what we refer to as a fiber. So imagine you have this kind of fibers, and then we now weave them into mats, different kind of product at the end of the day. So the whole idea is for us to be able to use these fibers that we get for different products that we have identified. This one in the middle here is what we refer to as a briquetting machine. Briquetting machine are actually solid fuel cells. So they are solid energy-based material that you get. So imagine you have a powder of, let's say, sawdust. You have treated it, you have added some form of binders, and you want to get your briquettes. So you pour your sample in here, and then once it's rotating, your fibers will just be coming out, your briquettes will just be coming out at this end. So these are for solid fuel cells application at the end of the day. Apart from this, these are just a few ones. There are still other machines that we still need to fabricate. But the funding agency releases the money in batches. So I think for the next batch of funds that we're going to receive, we need to also fabricate a weaving machine. Because once you have these fibers, they're just in strand. So I need to weave them together into a material, then we will now be able to make product out of that. So this is just a short overview of basically what we do here. Perhaps when we have another session or time, we can give you details of basically what we do and how we came about many of these.
So, sir, the briquettes that comes out of here, what do you use it for?
So briquettes are basically used for energy application, basically used for cooking, especially in rural areas where people do not have access to gas and electricity. So the briquettes are supposed to be like cheap energy solutions for those rural areas. So in addition to this, maybe when you also come, when we have another section, apart from these ones, we also have another solution which has to do with ceramic water filters. So they have made local filters that can be used in rural environment. And those filters are actually being used in one local government in Abuja. And they actually use it to get clean water. But also what we realize is when you give people something for free, they don't tend to really value it. So we make them to pay a token for that, and then they really appreciate it. So once those filters get blocked, they actually come and request for more. Okay. Just pay them. And then,
so for outsiders that are there that are watching, what's the innovation in these briquettes? What's the difference between it and the normal charcoal that is out there?
Yeah, so briquettes are actually clean energy technologies. They burn like gas. They do not burn like the way charcoal with flames
and dirty pots.
Yeah, they just give you the normal blue flames that you get at the end of the day. So briquettes are actually very clean technologies. The briquette actually lasts longer depending on how you have engineered the material. So if you have a briquette material, you can use it for a long period of time before thinking of changing it and then use another set. The most effective briquettes that have come about is basically the whole briquettes that have been manufactured in somewhere in Enugu. So we hope to be able to produce those kind of briquettes from biomass-based materials.
Thank you, Dr. Bello, for taking us through this process. there's a lot going on here at African University of Science and Technology. There's a lot going on in AUSTInspire Incubation Hub. All you need to do is to follow us on our handles, and you have access to information about what we are doing and when we are doing things, so that you can actually be part of it and benefit, especially if you have a business idea. Like I will always say, even if you don't have any business idea, come, let's borrow you some sense so that you can think as well. That's how it is. Thank you very much. Well, this is our 3D printing lab for AUSTInspire Innovation Hub. Most of the things you see here are locally fabricated, or some of them are imported and assembled here. This lab is actually for prototyping of products. So if we are done with you at the lab there, ideation lab, and there's need to prototype your products, this is actually where we design it, and you use all these 3D printing machines to print it. I will allow Alhaji Jibril, as I fondly call him, to do more explanations on this, so that our listeners and viewers can actually gain more insights into what is happening.
This 3D printing lab, it's also a startup under the AUSTInspire Hub. So as my boss said, it's for prototyping, and most of the materials here are gotten are sourced locally. The ones we get from China, like the computers and whatnot. So basically, if you can look around, you can see we're still building some of the 3D printing machines, but some have been built. If you can see over here, this is currently printing a Raspberry Pi case. It's also, I think during the COVID-19 period, we printed some not prototype, these are actual products. So these were face masks, some parts of face masks, so probably with the bands and all. But these are printed during the COVID-19 period. This is a kind of a hair strap. So
How it works is we have a filament, right? This is what we call a filament. I'll just show us. So basically, this is a plastic, right? It comes in different materials. So for example, this one is called PET. I believe should be PET G. We have ABS. We have even carbon fiber. We have wood. It comes in different plastic. So it depends on what you want to produce. So once you have your filament, you actually feed it into your 3D printers. Of course, before then, you must have a design of your product. So for example, this one, before you do anything, you must design it in your computer. You must create a 3D design of this full system. After that, we put it in a software called slicing software. What it does is from there, you can actually control things like the density of your parts. For example, how thick. So inside, we can make it to be hollow. So it will just be weak, or you can make it to be kind of filled up, making it strong. So you have to balance between, okay, these things are very kind of expensive. So you have to balance that strength and cost. Okay. Another thing this slicer does is it's kind of a dummy machine. Let me say it that way. It doesn't know what it's doing. So what it does is basically it's a human that is moving. You tell it, okay, go left, go right, go front, go back. Okay. So what that slicer does is it looks at your design and then breaks it down into coordinates, X and Y coordinates. Okay, let me just go into math. So basically it's just like going left, going right. So once you put it into the machine, this 3D printer reads those codes. So it tells it, okay, initially start at the center, pour the material for 1 meter, move back, come front. So that's how it keeps laying it in layers till eventually you have your full products, which is this. We as the operators, of course, we have the knowledge of this full process. But then you now coming to us, everything is up to you. You can come to us at any point. So you can come to us at the initial stage. Maybe you have your design on paper. We help you design it in computer, put it, slice it for you, and print it for you. So at any point you come to us, we are always willing to help. We're ready to help you. So it depends on what you want to do.
Okay, awesome. One last thing. Is it possible to see this print something for us? No matter how small. You can print a razor blade.
Okay.
Oh, we don't have a design already.
Yes. So as you can see, this was printed. It takes probably it will take some time,
Okay.
but yeah, this was printed, right, with this same machine, and all these were printed with this same machine. So it's the disadvantage of this. It actually takes a little bit of time. So for example, to print this, it can take as long as 5-6 hours to actually print it. And so because we are doing this as a full scale business, that's why we have about 20 of them here, so that we can actually meet our consumer at a time.
Okay. So
Then-
when you say this printed from here?
Yeah, this
where's
was
like the output tray or something. Where once your stuff finish printing, where do you find it?
okay. Okay, no problem. So basically, like I said, how it works, it's everything is laid down here.
Oh.
So this part is called the nozzle.
Okay.
So from there, everything, okay, it's maybe, I don't know if we'll wait so that when it starts moving, we'll capture it. It's kind of hard to hit off the
Okay.
bed.
Okay.
So while it's doing that, okay. So the advantage of this is kind of what we call rapid prototyping, right?
Okay.
So normally, conventionally, if you want to produce something, a product, you have to go and produce something like a mold, get a machine that depends on what you want to do, that kind of melts your rubber, kind of then hits it with the mold to produce everything. But then if you look at that, if there is a mistake with your product, it will be very expensive. Because basically that means you have to go and change your machine entirely. So what this helps you to do is you can easily make your products, test it, see, okay, are there any defects? If there are defects, you can easily, quickly change and rectify those mistakes and keep printing. It's kind of much, the expense or the cost is much lower than compared to you actually producing your machine. That's your production machine, and then finding out that there is a problem there.
Later on.
So that's the advantage of this.